Hello everyone, welcome to Maths IAC. Let's have a look at another question about Kirchhoff's laws. Now we've done 3 questions before similar to this. This is the 4th one, and let's have a look. Now we need to mark the current in a circuit like that to start this. So I can start from maybe from here. So let's say the current here is capital I. The current through this branch is capital I, capital I, capital I. Now, here's a junction. It will split as lowercase I, and this is I take away I. And I take away I take away I. Now, this I goes through this one, and this one. These two add up again to give capital I. Right? That's quite straightforward. Now, let's go and label the circuit. Okay. Now we can write the Kirchhoff's second law to any of these loops, to one on the left hand side, one on the right hand side, or the big one. Let's just pick one of them. Let's write it for the first one. So let's define the loop. Let's do it from A, B, C, F, A. Okay. So I'm going to write sigma EMF is equal to sigma PD. Okay. Now let's do the walk. So I'm going to start from A, and first I'm going to do a complete walk looking for any EMFs. Let's do the walk. Starting from here. Oh, there's one. And now this one is pushing the same way I'm going. So that's plus 1. 1. And I'm going this way. Oh, here's a 2. And that's also pushing the same way I'm going. So that will be 2. So 1 add 2. Those are the EMFs. Now let's do a second walk looking for PDs. So starting from here, I can see here it's 3I, the product of IR. And I have another 3I. Okay. Nothing. Oh, here there's 6 lowercase I, and that's it. So let's write them down. 3 capital I plus 3 capital I, that's the second one, and the final one is 6 lowercase I. So I can simplify it. 3I add 3I is 6 capital I plus 6 lowercase I is equal to 1 add 2 is 3. Right. Now I can divide everything by 3 if you want. 6 divided by 3 is 2I plus 2 lowercase I is equal to 3 divided by 3 is 1. That's your first equation. Now let's write the second one. Let's take the full circuit, the big one. So starting from A, we're going to go from A, B, C, D, E, F, A. Sigma EMF is equal to sigma PD. So sigma EMF, let's do the walk. Starting from here, no power supply, nothing here, nothing there, nothing there, nothing there. Oh, there's only one. That's 2 volts. It's pushing the same way I'm walking. So that's just 2. Now let's do the next walk to look for the PDs. Starting from here again, 3I, 3I, 6 times I minus I, also 4 times I minus I, and nothing else. So that's 3 capital I plus the second 3 capital I, 6 I minus I, plus 4 I minus I. Now if you want, you can combine these 6 and 4 to get 10 and 3 to get 6. That also kind of simplifies it, but okay, let's do it this way. So I go 2 is equal to 3i at 3i is 6i plus 6i plus 4i is 10 capital I. 6 times negative I is minus 6i minus 4i. Let's simplify it further. 6i add 10i is 16 capital I. Minus 6i minus 4i is minus 10i is equal to 2. I can half everything. So 8i take away 5i is equal to 1. This is the second one. Now all you need to do is just do simplification. I'm going to quickly do that and let's get the answer. So I've just done the simplification. So the answer, lowercase I is 0.23 amps. Capital I is 0.27 amps. Now let's see how these current values can be applied to the circuit. Now I just got a rough sketch of the circuit here, like the same circuit. Now let's put the actual current values and see how it works. So capital I is 0.27. So we know the current that goes out from here is 0.27 amps. 0.27 comes here, 0.27 amps. Then lowercase I is 0.23. Oh, so that's 0.23 amps. So 0.27 take away 0.23 is 0.04 amps, which is the current through this one. 0.04 amps go through this one, here, here. Now that 0.04 add 0.23 comes from this branch, and that gives you 0.27. So everything works. So I have just marked all the current values in the circuit.